Hi, Assalamualaikum. My name is Salina binti Abdullah. My metric number is 22003-159, and today I will be presenting about transmission lines and waveguides. So let me introduce what is the definition of transmission lines. Transmission lines are commonly used in power distribution at lower frequencies and in communications at higher frequencies. A transmission line basically consists of two or more parallel conductors used to connect a source to a load. So for the example of source, you can see here is hydroelectric generator, a transmitter, or an oscillator. For the examples of transmission lines is coaxial cable, a two-wire line, a parallel plate or planar line, a wire above the conducting plane, and a microstrip line. So these are the pictures that you can relate it with the examples. As for the definition of waveguides, a waveguide is a hollow metallic tube or channel designed to guide and confine electromagnetic waves over long distance. Waveguides are typically made of highly conductive metals like copper, brass, or aluminium to minimize signal loss. Waveguides guide waves through their internal reflection from the metallic walls. We have electric and magnetic fields within the waveguide, which are transverse electric (TE) and transverse magnetic (TM). Transverse electric means the electric field component is perpendicular to the direction of propagation while the magnetic field is parallel to the walls. Transverse magnetic TM is means by the magnetic field component is perpendicular to propagation and the electric field is parallel to the walls. As I mentioned in the slide before, the transmission lines have their example, which is coaxial cable. So what is coaxial cable? It is a widely used type of transmission line that consists of a central conductor surrounded by a dielectric insulator. The insulator is then encased by a braided outer conductor which acts as a shield. Coaxial cables are popular for RF applications due to their good shielding properties. The outer shield effectively protects the inner conductor from external electromagnetic interference (EMI), ensuring signal integrity. Their operational principles are when a signal or voltage is applied to the central conductor, it creates an electric field that extends outward. This electric field interacts with the charges in the outer conductor, inducing a current to flow in the opposite direction along its inner surface. Coaxial cables are used in some medical equipment such as electrocardiogram, ECG machines to transmit electric signals from body for monitoring purposes. The second example of transmission lines is twisted pair cable. Twisted pair cable is another common type of transmission line that consists of two insulated conductors twisted together. Due to the close proximity and twisting of the wires, the electric field induces a current of opposite polarity in the other wire. The twisting of the wires helps to partially cancel out external electromagnetic interference (EMI) picked up by the cable. A higher twist rate leads to great cancellation of electromagnetic fields and minimized crosstalk. Each wire acts as one conductor in the transmission line. The insulation prevents the wires from directly contacting each other, ensuring proper signal transmission. Today, twisted pair cable in various categories with improved specifications is still widely used in internet networks to connect computers, routers, and other devices. So, let us move on to waveguides. Waveguides, we have three types of waveguide, which is hollow waveguides, dielectric waveguides, and acoustic waveguides. For the hollow waveguides, the example is for radio waves and microwave. For the dielectric waveguides, it is meant by higher frequency of EM spectrum like visible light. And the last one is acoustic waveguide, which is common for sound wave, mechanical wave, or vibrations. I'll be explaining about the type of waveguide one by one. The first one is hollow waveguide. Hollow waveguide means hollow metallic tubes or channels, typically rectangular or circular. Different wave modes TE and TM exist with specific cutoff frequency. In TE modes, it have the various sub-modes designated as TE-MN, where M and N represents the number of half wavelength variations in the E fields across the X and Y dimension respectively. Its advantages are high power handling capacity, where they can handle high power electromagnetic wave, making them ideal for microwave heating. They efficiently heat materials through interaction with the electromagnetic fields within the waveguide. As for the dielectric waveguides, the dielectric waveguides utilize a dielectric material which is insulator as the primary guiding medium. This dielectric material can be in form of rod or a slab surrounded by air or another medium with a lower refractive index. It undergoes total internal reflection and remains confined within the core. We have two types of dielectric waveguides, which is single mode waveguides and multi-mode waveguides. In single mode waveguides, it have a core diameter to support only one mode of light propagation at a specific wavelength, while in multi-mode waveguides, it have a larger core diameter and offering higher light carrying capacity such as modal dispersion. The last one is acoustic waveguide. Acoustic waveguides steer sound wave pressure variations through specific structures. These waveguides, which come in various shapes like tubes, horns, and even plates, utilize the materials they made from metals, wood, or air to confine and channel sound wave. Acoustic waveguides can achieve various feats, such as controlling sound direction in loudspeakers, amplifying sound in horns, and shaping the acoustic for a room. It have their benefits, where waveguides can act as acoustic filters. This sound wave travel through the medium of the waveguide, experiencing reflections at the boundaries of the structure. As for the applications in transmission lines, we have a lot of examples, such as telecommunication networks that we have used in nowadays and we still use it. The next one is computer networks, microwave communication, and radio frequencies. As for the waveguide, we have radar system, microwave heating, satellite communications, and MRI. So that's all from me. I hope you can enjoy this video. Thank you.